We have done wonderful experiments related to acids with metals and acids with metal carbonates. Now, one experiment that is left out in this chapter is the neutralization reaction. Neutralization is nothing but reaction of acid with a base. Are there any real world examples of this? Let's take an example of agriculture. Imagine a farmer went to the agriculture department and got tested his soil sample. That means he collected a bit of soil, he went to the agricultural society or the department, and what they do over there is they mix water to this soil, they filter out all that water which has all the minerals or acids or bases inside, and they boil it for a long time. Once boiled, you have concentrated solution left out. In that concentrated solution, they do various tests like pH test or basic litmus test. These tests will indicate if the soil is acidic, basic or neutral. So why do we need to know this? The reason is, if the soil is too acidic or too basic, then it would not be useful for planting anything useful. Most of the plants that we know, or most of the crop that we know, it could be potatoes, rice, it could be any plant-based products, they need to have a range of pH. They can't be too acidic, they can't be too basic. So imagine a farmer found out that his soil is too acidic. Then what the agricultural scientist would ask him to do is, they would give him a basic solution, and they would ask him to mix this basic solution or a base into his soil. So acid and base will react to make it a little bit less acidic or maybe even neutral. Imagine another farmer found that his soil is too basic, that means extremely basic, which would not be suitable for growing any plants. Then what would they ask him to do? Will they give him a basic solution or an acidic solution? Yes, your guess is correct. Since the soil is basic, so they will ask him to add acidic solution to it to make it neutral. So I already told you about antacid, ENO, that we are familiar with. When stomach has excessive acid, we need to drink a base. So you also know about bee stings. When a bee stings your skin, it releases acid. So if you put base on top of that sting location, then you can neutralize it and the pain would not, or the pain would go very fast. So you understood the reason why neutralization is important in the real world. Now before we start with the experiment, I have a table. Check out this table and then we will start with the experiment. So it's a lengthy experiment, so I have to collect a lot of data. In the first column, what we'll write is, we'll just write it as solution. And in the second column, we can put color. And in the third column, we can say nature. When I say nature, what I mean is it acidic, basic or neutral? The first solution that we are going to take is hydrochloric acid, HCl. In this hydrochloric acid, we will add a little bit of phenolphthalein. Phenolphthalein solution, I'll show all that in a while. Phenolphthalein solution. So instead of writing this whole thing each and every time, let's use a short form of HP. H stands for hydrochloric acid, P for phenolphthalein. HP solution is a mixture of these. Can you guess what is the color of HCl and what is its nature? Okay, we will do the experiment related to that. Now, when we mix with phenolphthalein, is there any color change? Is there any change in nature? Now, once we have this HP solution, we will add a little bit of base in small quantities. The base that we are going to use is ammonium hydroxide. Ammonium hydroxide is NH4OH. Okay. Now, then we are going to add exact quantity of the base required to neutralize, exact quantity of base to neutralize. right? And then we will check the color and the nature. And we can also additionally see what happens if you pour excess. That means additional than required. Okay. Excess quantity of base. That means with acid, if you add exact quantity, can you guess the nature of it? When I say exact, in proportion, that would be neutral. If you add less than required, it would continue to be acidic. If you add more than required, it will become basic. So that is what we want to prove in this experiment. We could stop at this point, but we are doing something more than that. Okay. Now let's go ahead and start with the experiment. I have arranged 3 small beakers over here. In the first one, I will add dilute hydrochloric acid. It's not dilute like the last time. I have added excess water here so that I can, even if the kids accidentally touch it, nothing harm or no harm would happen to them. So this is very, very dilute. It's actually 1 molar hydrochloric acid. In this beaker, I am pouring our base, that is ammonium hydroxide. So I have my acid here, I have my base here. This is my test solution. This is for testing. This beaker, I'll use it for testing. And I have red litmus and blue litmus. So I'm adding a little bit of acid here. And I want to make it a little more dilute. Okay. Now, before we start, here is my first test. So this is before adding phenolphthalein. This is my test solution. If you remember, this is acid, this is base. I am dipping blue litmus into my test beaker. And please check this. Has it changed to red? Yes. So blue has changed to red. So obviously if blue changes to red, you should not see any changes with the red litmus. Now this is my red litmus. Red remains red. So clearly this proves that this is acidic in nature. Hydrochloric acid is acidic, so that's the reason blue has changed to red. Now in this test beaker, I will add phenolphthalein. Can you guess what is the color of phenolphthalein? It is colorless. So I'm adding some phenolphthalein here, 3 to 4 drops, and I'll just shake it gently so that the solution, phenolphthalein solution, dissolves in the acid. Now let's see if the nature has changed. Again, blue litmus has changed to red. So I don't even have to do the red litmus test because blue has changed to red. So adding phenolphthalein does not change the nature of this acid. Okay, it's still acidic. Now let's start with the neutralization. I'm going to add a little bit of base to this acid. Very small quantity. I'll add a little more and a little more. Now let's check if there is any change in nature. Blue is still red. Blue has changed to red. That means it is still acidic. Now I will pour away some of this solution so that I can continue adding the base. So observe the color changes. Maybe I will zoom in a little more into this so that you can see if any color changes are occurring. In fact, I'll hold it upwards in this direction. Now please see. If you would have observed, there was a slight pinkish coloration. So let me zoom in further. When I add small quantities of the base, have you seen the pink color? You saw it for a long duration. During the initial stages, the pink color immediately vanished. That indicates that it is highly acidic. But now when I added the base to this acid, the pink color persisted for a long time. Whenever pink color persists for long duration, it means it is coming close to neutral. And if it completely changes to pink, then it is basic. Now I'll reduce the quantity. I'll add only a little bit over here. You can check the pink color is persisting. which is a good sign. Maybe we have come to the neutral, but in fact the pink color is not at all vanishing. So it is at the border between neutral and basic. Let's check once if blue still changes to red. Okay, now see this. This is my blue litmus. And check this. Blue remained blue. And let's check red. If red has changed, if red changes to blue, then it means that the solution has already become basic. The pink color generally indicates basic, but it is very, very dull pink. So I'm hopeful that red will remain red. No, in fact, as you can see, red has changed to blue. That means we skipped the neutral. Instead of going from acidic to neutral and then to basic, we directly went into neutral. We did not do the neutralization, we directly went into basic. Now I am going ahead and adding some acid to make it neutral. I want it colorless but not acidic. Only a little bit I have added. Now the pink has almost gone. Maybe it is like mild pink. I'll add few more drops of acid. Now there is no pink anywhere over here. And now let's check again our blue and red litmus. If blue remains blue and red remains red, that means we have achieved our goal of doing the neutralization. This is perfect. Blue is blue. There is no change in blue. Now let's hope. There is nothing to hope actually. We know that since it is not pink in color, definitely the red will remain red. This is my red litmus. And see that? That's red. Red remained red and blue remained blue. That means we created our neutral solution. We had to go back and forth, but it's alright. Now we have learned that whenever we pour excess, it becomes basic. Now let me pour excess of this solution and you will see it to completely change into pink color. Pink indicates it is no more neutral, it is basic. So in acidic, you see colorless with phenolphthalein. In neutral, you see colorless with phenolphthalein, but in basic and phenolphthalein solution, we see pink in color. Let's summarize all these results and we will close this chapter. Now, let's start writing these results. We already know HCl color is colorless and its nature is acidic. Why? Because blue changed to red in this solution. We already tried this. I'm just summarizing the whole topic. Now, HCl and phenolphthalein together, after pouring our colorless phenolphthalein, we have seen that it still remained colorless because phenolphthalein does not change the color of acids. And this one was also acidic because blue changed to red. Now, when we added small quantity of base, our ammonium hydroxide in this hydrochloric acid and phenolphthalein solution, it continued to remain colorless and our litmus test was also blue to red. So that's why it's still acidic. Now here we added excess base and then we again came back to neutral. But imagine if we had greater control and if we add exact quantity of base to this acid, then it continues to be colorless, but blue does not change to red and red does not change to blue. Blue remains blue, red remains red, and this is our neutral solution. Okay. And lastly, when we poured excess base, we saw this pink colored solution. The pink colored solution indicates that it is basic, and we haven't done this last part. Just by seeing the pink color, we have decided that it is basic. But for the pink colored solution, I have the red litmus. When I dip it in, red changes to blue. This indicates that it is basic in nature, where red is changing to blue. That's it. That's an amazing table which summarizes all our observations. Now let's look at this reaction. Whenever acids react with bases, it creates two products, salt and water. That means you're getting salt solution. and also some energy can release. This energy depends on the concentrations of acids and bases. For highly concentrated acid and base, you will get lot of energy. For very dilute acid and base, we might not see lot of changes in the temperature. So I hope you understood the neutralization. It has lot of industrial as well as household applications where acid and base react to become neutral or to form salt and water. Thank you for listening to this entire class.